Happy New Year, everyone, and welcome back to AI Pods. So today I will talk about how can you customize large language models, popular large language models tailored to your needs. We all know large language models are fantastic. They are terrific in doing their jobs, getting the answers to your general queries. But what if you want the LLMs to answer your domain specific questions? So here some of the popular methods like RAG, fine-tuning, multi-agents comes into play. But due to the ease of the implementation and the lower cost, RAG is gaining popularity. RAG, which is the Retrieval-Augmented Generation. And today the video is all about that. Let's look into this. So as a part of this video, I will introduce you to this concept using a simple use case. Then we'll talk about the process on a broader level. Then I will cover the entire step-by-step implementation. And finally, we conclude with major takeaways. So to give you a better sense of how RAG works, let me take a marker here. Let's look at a customer support use case. So imagine a company is using a chatbot to assist its customer with the product issues, right? So with RAG, the LLM connects to a database, to your company database, let's say here facts, some troubleshooting guides, product manuals, and so on, right? So if you ask model a specific question about your organization return policy with respect to specific product like electronics, the model would be able to answer it in a very precise manner. So instead of hallucinating with a wrong response, the RAG enabled model retrieves the most relevant information from its knowledge base and incorporates it into the response. The whole essence of the RAG is the model, the base LLM doesn't need to remember everything. Rather, it just needs to know where to find the right data and accordingly output the result. Here, in this case, where to find the return policies and output the result. Think of RAG as giving your LLM, general LLM, a personalized reference library, right? So instead of retraining the model, you are connecting your base model to your custom knowledge base. So this supplements the model's general knowledge by pulling specific information on demand. Now let's look into the how part. How is the model able to answer to a domain specific ask using RAG, right? So this is a overall process workflow of this RAG implementation. So when the user asks certain query, this query is first converted into an embedding, right? So if you recall one of my earlier video where I explained the entire concept of embedding vectors, how the large language models understand any text, any input, and how these are converted into embedding for the model to understand the semantic meaning behind those text, right? So once the query is converted into vectors, the model retrieves the relevant documents from the vector database. This retrieval step matches the query embedding against the document embedding stored in the vector database. So you can use the vector database of Milvers, Pinecone, Chroma database to name a few. And in the embedding, there are certain embedding models which can be used to convert your input text into the vectors. So these are, to name a few, these are Cohere, OpenAI, and so on. Right now, let's zoom out a little bit of what happens in the vector database. So you have stack of multiple documents connected to your vector database, right? Let's take one document and see how are these converted into vectors and mapped into vector database. So I will name it as D1, right? So the very first step is to break down this document into small chunks of data. I have taken 5 chunks and it could be anything, right? So depending upon this chunk depends on number of words or number of paragraphs or number of pages, right? And for these breaking of this document into chunks, you can use the framework by LangChain. Now each chunk data is now converted into a vector form. Let's see, converted into vectors using the embedding model like OpenAI Cohere, to name a few as mentioned earlier. So I have shown its vector representation in a 3D format due to the graphic limitation, of course, but the dimensions could range into hundreds or even thousands of parameters, right? So numerically, if I represent this vector, it could be in the form of a matrix up to the up to some dimensions what we define in the model. So here I have taken 512 because of the, as taken reference from the attention is all you need research paper, but it is something which varies, right? So these value are basically like the coordinates of all the text that will be present in the that are present in the chunk, right? And these values also carries the semantic meaning of those text. This is the beauty of the embedding concept. And if you can reference my, if you can refer to my video of that I had created on the embedding some months back, so you will get a fair idea of what how does this concept works, right? So in a similar way, each chunk will have its vector form and will be represented in the form of the coordinates, right? Now this vector data corresponding to each chunk is stored in what we call as a vector database. Note that this vector information is also mapped to its corresponding document ID, right? To give a trace of all the sources. Now let's see how retrieval process identifies the right answer to your query. So when a query comes in, its vector, which has been converted using the embedding model, its vector is compared with the vectors of the stored chunks using a similarity measure like cosine similarity. So this helps to determine which chunk is the closest match, right? So cosine similarity, just to give you a brief, so cosine similarity is used to compare two vectors, which is equal to the dot product of the vectors divided by the product of their lengths. So if the theta is 0, the value will be 1 and these two vectors will match, right? Once it is, the retrieval process identifies which chunk is the closest match to this query vector. As a next step, this retrieved chunk serve as an additional context to the LLM, right? So the LLM uses this retrieved context to generate a more accurate and context-aware response. So this LLM, this base LLM, which was trained on a generic information, now it has got some additional context through this RAG process, which help it to understand the query, and eventually it is able to generate the more precise response. So here we are. RAG allows LLMs to access external knowledge in real time by converting query into vectors, then converting documents into vectors, matching queries with the stored information, and generating the precise answers. So now you understand why RAG is such a powerful concept, especially when you need your model to be context aware, but without modifying the parameters of the model, without giving training to your model, right? It's a perfect for the situations. I want my LLM to know my data. Hope you like this video and learned something new. For more such insights, feel free to subscribe to my channel. Thank you.